Hello to everybody in Algebra 2. Welcome to our virtual class here. Um, Before I get started, I just want to go ahead and say that if you want to do any tutoring on Friday, I have a couple extra sessions open there for you to ask questions. As always, you can email me if you have questions. Um, find some way to get your questions answered, okay? So let's go ahead and jump into it. So this week we're going to look at our supplement first, as always. So last time, or last supplement before our midterm, was about factoring by grouping. Okay, now we're going to factor trinomials. So trinomials, right? So tri is 3, and nomials like name. Okay, but factoring trinomials. Okay, but this time we're going to say when a does not equal 1. Okay, so this is an important thing to know too. So we've always looked at this form here: a x squared plus bx plus c. Right. So I'm going to look at this today with a couple different things here, right? But basically, we're going to break down this middle term into two pieces. So first example is 3x squared minus x minus 2. Okay, so we're going to start out the same way that we've done before, right? We're going to start with the t-chart. So we have our t-chart here, or sometimes I call it my multiplies to adds to chart. Okay, it's MTAT. So multiplies to, and it's always my letter A, my letter C, multiplies to. So it's no different here, okay, but when I apply it, it'll be a little different, right? So A times C, that'd be my 3 and my minus 2, so I have minus 6. My other 2 is my B term. My B term is minus 1. Or my equal sign here is a little bit crazy, okay, but equals minus 1. So when I think about those numbers, right, and say, okay, well, what multiplies to minus 6 and adds minus 1, right? Well, I think, oh, well, let's just start with the easiest ones, right? I know I have to have one negative number as part of it, so let's just do minus 6 and positive 1. So minus 6 plus 1, that gets me minus 5, right? And then I say, well, about minus 3 and positive 2. Well, minus 3 plus positive 2 is minus 1. So, all right, just the second one in, I found one that works for both of these things, right? Minus 3 times 2 is equal to minus 6. I just kind of squished minus 6, okay? And then it adds to minus 1. So it's works for my problem here, okay? And like I said, I kind of highlighted this middle term here in this top part. So it breaks those pieces up. So when I write this here, right, my middle term, I have term 1 and term 2. So basically, kind of write it like this. Okay, my middle term here, 3x2, and my minus 2 are going to be over here. And I'm going to, oops, and I'm going to break my middle term into these two numbers that I just found over here. Okay, I just found those two numbers. So when I write them out, I just say minus 3x plus 2x. Okay, well, stay with me for a second, right? So if I break those two numbers up like that, because I found the numbers that multiply to a times c and add to b, if I add these numbers up together, right, what do I get? Minus 3x plus 2x, right? Hopefully you can see, right? Minus 3x plus 2x would just equal minus x, or I could have written minus 1x up there, okay? And you'll see as we go along, but writing the negative number first, right? So I found minus 3 and 2. I could have written plus 2x minus 3x. I could have written in any order, but I like writing the negative one first, and maybe you'll see the reasons a little bit later, okay? But now that I can do that, we talked about factoring by grouping several weeks ago, right? So let's go ahead and factor by grouping. So if I think about factoring by grouping, right, what did I do? I said, oh, let's look at these two terms, and let's look at these two terms. So these first two terms, they have a 3 in common, and they have an x in common. So if I did that, then I do x minus 1, right? And then for the second group of terms, I have plus, and then I have 2 common to both of those, and I have x minus 1, right? And you say, well, why do you have x minus 1 there? Well, I'm factoring my 2 out, right? So I factor my 2 out of my 2x, right, up here, right? Then I'll have x left, and I factor a 2 out of my minus 2, I'll have minus 1, okay? So hopefully you can see that, and you can multiply those back out to make sure you get the same thing as before. Now we can go ahead and write this. So we have, right, we have our 3x plus 2, right? Those both have x minus 1 as a factor, right? So what I can do is I can say, okay, 3x plus 2 in parentheses, and then I can write x minus 1, just like that. Okay, and that's my final answer. And I could go ahead and multiply this out just to make sure I get my original answer, right? But I would do this, I do 3x times x, right? So I go ahead and do the distributive principle. I'd have 3x squared minus 3x, and then I'd have plus 2x, right? So 3x minus 3x plus 2x would end up with minus x, and then this last part, minus 2, which is what I ended up with, okay? So hopefully you can see you can multiply that back out. All right, now if we had something a little bit trickier here, right? So I don't know exactly what to say here, but let's just say we had um, something written more like 2x squared, and wrote it as plus, and then I wrote plus 2x plus x plus 1. Okay. I don't think you have this. Yeah, you don't have this on your paper there. Then I want to factor again, right? So I'd say, okay, let's factor by grouping, okay? So I'm not breaking up I'm not doing my t-chart yet, but similar to what we did several weeks ago. So then if I factor this out, I say, okay, well, I can factor 2 and an x out of this first part. I have x plus 1 here, right? Okay, and then for this last part, right, looks like I just have plus x plus 1. Okay, and you say, oh man, how do I break the rest of this part down? Right, I just want to show you this because sometimes people get tripped up with this because they don't see, right, that I really could factor a 1 out here, right, because 1 times everything on the inside really is right is going to be the same here. So I go ahead and say, okay, well then that would be like, doing this distribution again, okay? So then I could write 2x plus 1, right? So that's my 2x right here, my plus 1 there, and then I could write x plus 1. Okay, that's a little diversion there, but hopefully you guys can see what I did there. Now let's go to our last example on our sheet there. So we have 10, so I'm going to change my color back to blue. So that looks different here. So I have 10x squared plus 13x minus 3. Okay. And I guess before I go further, right, you guys might remember I divided everything by this a term before, right? I mean, like, hey, let's divide everything by 10, right? Well, why can't I do that here? Well, because, right, what am I given? I'm given just these 3 terms, but I was not given equals 0, right? I was just given a value. So if I have an equal sign, I could do that, okay? because that means that I have a balance, right? I have one side is equal to something, the other side is equal to something, so I can kind of go up and down equally, and my equation will still be true. But in this case, I'm kind of stuck with no other option here, right? I have to go ahead and do my a times c, right? So a times c, so I have minus 30, and then I have 13. So minus 30, 13. I can think of a couple different things here, right? But I have to know, I know I'm going to have a negative, so I can do minus 30 times 1. That obviously is not going to work, right? Because if I do minus 30 plus 1, I'll have minus 29. And we need to write that out necessarily, okay? Then I'm going to think of other factors and saying, oh, well, you know, what about, right now I can see that if I had minus 2 and positive 15, right? Minus 2 plus 15, right? It's always helpful to write these things out. Then I'm going to end up with 13. Whoops, 13. Okay, now that I have my two numbers, like I said, there's nothing that says that you have to write the negative term first when you write out the expansion of this middle x part, but that's what is easiest. Okay, so you write 10x squared minus 2x plus 15x minus 3. So when I go ahead and factor this out, right, and say, okay, what factors out of these first two terms, right? So here, let's show this again, right? I'm factoring by grouping, right? And then I'd say, okay, well, 2x comes out of both of these right here, right? So then I have 5x minus 1, and then over here, right, I have plus 3, right? Only 3 because x isn't part of those, and then I have 5x minus 1 here, right? So if you have something that sets up like this, right, you can be more sure that you did it right because you can see you have two different parts, right? You say, okay, I have 2x plus 3, and then I notice that this term or this group of terms here is exactly the same. Okay, so then I have 2x plus 3 and 5x minus 1. Okay. I think that's pretty much all I want to cover. The only thing that I could say here is that if you need to, right? So let's uh, think about if you need to swap these terms, right? So if you wanted to swap the order of these terms, you could, right? So if minus 2x was listed second, for example, then you couldn't really factor anything there. So it would look a little different, right? So then if you had, let's just say we write that same example above, we had 10x squared plus 15x minus 2x minus 3. Okay, right, so then you say, okay, well now I'm still looking at factor my grouping. And then over here, right, we say, okay, well we can factor out 5x, and then we have 2x, and we have plus 3, okay, and then over here we have minus, okay, and we just have minus 2x minus 3, okay, because I don't have anything common here, right? But what I did earlier, right, and when I did this example here, right, we can factor a 1 out of anything. Well, I can also factor a minus 1 out. So let's show it like this. We'll show it in red. I can say minus here, but if I put parentheses around here, then I'd have to say, oh, well, I'd have to do plus 3 there, right? And then outside here, right, I'd have the number 1, right? So then when I write this one, I could do the exact same thing, right? And I'd say, okay, we have 5x minus 1 as this first parenthesis set, right? And then over here, then I say, oh, and then I have 2x plus 3. So I'd have the exact same thing that I had right up here. It just is maybe a little bit easier to do the first group that they had over there, right? But if you get mixed up here, right, you can swap the order, make sure it's exactly the same, multiply it out, whatever helps you there, okay? All right, practice a couple of those if you want to, and then we're going to move on to the lessons here in the video, so you can pause, continue, and we'll just go on to lesson 68. Okay, so lesson 68. So scientific notation. So we've talked about this before, and you guys have touched on it in your science classes. So it's a very useful way of writing really big numbers and really small numbers because we're not writing so many zeros or point zero zeros, okay? And then we're also going to talk about powers and roots, which we've also talked about before, but we're going to talk about in a little more detail here. Powers and roots. So if I want to estimate something using scientific notation, right, I would like to use my calculator as well, but let's go ahead and just look at example 1 here. So example 1, I really do want you guys to use your calculator. Make sure you can get the right answer using your calculator. But if I have minus 40,652, okay, 652 times 10 to the minus 4, and then it's multiplied by, and I'm going to run out of room here, but it's 0 point, and then there's 3 zeros, so 1, 2, 3, and then 324 times 10 to the 11. Okay, then I can see if I can estimate this, right? So then I say, okay, well, my decimal place right now in this problem is right there, and obviously it's sitting right there in that one. Okay, so if I want to simplify this a little bit, I can go ahead and say, okay, well, I have minus 4, and I can say 0.0652, right? Now, if I'm moving to the left, right, my exponent is going to increase in value, right? Because if I have a big number and I make it look smaller, right, then I have to have some way to undo that, right? So it's just like if I'm multiplying by 10, multiplying by 100, right? So here, when I do this, I'll do times 10 to the, right, how many decimal places would I move? I moved 1, 2, 3, 4, right? So I'm going to add 4 to my number already, so it's going to be actually minus 4 plus 4 is 0, so I have 10 to the 0, and that 0 is there, but what do we know about 10 to the 0 or anything to the 0? It's just equal to the number 1, so I can write it there, or I can just write 1 if I want to, okay? It's just going to be like that. And now I'm going to be multiplying, okay, and I might put this in parentheses just to make it clearer. This one, I'm moving the other direction, so I'm making a small number look bigger, right? So I'm moving 1, 2, 3, 4 places as well, right? But I'm going to subtract those decimal places from that exponent. So I'll have 3.24 times 10 to the 7th, right? Because I'm subtracting it from there, right? So 7 here, maybe I'll make my 7 a little clearer there. Okay, now that's a lot easier to plug into my calculator and a lot easier to estimate, okay? Because now, right, if I wanted to plug it in the calculator, I can. Or if I want to estimate it, I can just say, hey, this is minus 4. I'm going to multiply it by 3 times 10 to the 7. Let's just say, for example, okay? And then, right, what do we know about these, right? Well, we know that I can actually just multiply these together, right? I can multiply, it's sort of like my coefficients and my variables almost, right? But I have my minus 4 here, it's times 1, so I can just write it like that, and then I have 3, so I can get minus 12. And then I just have minus 12 times 10 to the 7. Okay, so that is the estimation of my answer. This is going to be pretty close to that. Go ahead and use your calculator just to make sure you can get that. But that's what they want you to get for that one. All right, now let's go on to roots here. All right, so example 3. Example 3 is about these roots. So this one looks a little funny, right? You probably have not seen anything like this. It's this square root bracket thing, but instead they have a 3.28, having a hard time putting it in the right spot here, 3.28 here, and then they have it 50.42 in the middle here, right? So on the midterm and on the review, right, you guys reviewed a little bit of powers and exponents. Right, when we see something like this, we go ahead and say, oh, well, we just do 1 over this number here, right? Because there's actually nothing outside of this parenthesis, right? There's actually number 1, but it's just assumed, right? But otherwise, if there was something here, right, if there was a 2, then I would say 2 over that number, okay? But anyway, I'll go back. Digress. Okay, it's going to be 50.42, and then it's going to be raised to the 1 over 3.28. Okay, and you can go ahead and plug that in your calculator. When you plug it in your calculator, be very careful, right? Do 50.42, and then you can raise it. But then when you raise it, I'd put parentheses around that raised part. Okay, just to make sure that your calculator doesn't raise it to the 1 and then divide it by 3.28 or whatever, right? Okay, let's talk about example 4. Example 4 has a couple problems I think that are useful because we're not used to seeing these very often. Okay, but you can have 9.26 and it's raised to 4.58. You want to go ahead and make sure you can get that in the book there. But the answer is there, but you're just going to plug it in your calculator just like that, right? And then if you have something that looks like B here, B is a little more complicated, right? Because it looks like this, 9.26, but then it has a minus 4.58. Okay, so with your calculator, you can certainly put it in your calculator like this, right? And you can do it like this. But what do we know about the rules for exponents? Well, there's this rule called the quotient rule, right? And when you think quotient, just think division, okay? Quotient rule, okay, right? But that's just, maybe it's an antiquated word, okay? But we have quotient rules. So the quotient rules say that if I have something like x to the minus 1, I can move it to the bottom just by doing this, right? And then my actual exponent becomes positive, or it switches sign, okay? So then for this over here, right, I can just go ahead and say, oh, okay, well, I could calculate it like this instead, right? I can say 1, and then I can say divided by 9.26, and then I can raise it to 4.58. Right, so I can do 9.26 raised to 4.58, figure out that number, and then I can do 1 divided by that answer, okay? All right, that covers lesson 6A. There's nothing really crazy about this one. I guess I just say make sure you know how to use your calculator with all these, know how to simplify your scientific notation, which you guys have done before, right? But if I'm moving left, right, just like this first one, I have to increase my exponent value, right? It was minus 4, and then I moved over 4, so it's minus 4 plus 4 came to 10 to the 0, which is just the value of 1, right? And then the opposite for my other one there. Okay, you can pause and do your practice if you want to, and then we'll move on to lesson 69 here in the video. Okay, so lesson 69. It's about this gas law case, the gas law. So the gas law, basically, right, we're going to talk about this equation where it's P1 V1 over T1 equals P2 V2 over T2. Okay, and this is pressure. Okay, P is pressure, V is volume, T is temperature. Okay, and we're doing really nothing really more than algebra here. Okay, we're not really getting into science here. Okay, but it's the same principles here, and we want to see how we can rearrange the equations. So if I go to, if I'm talking about this, right, this is at time 1, okay, so this is like time 1 here, make it a 1 here, and this is at time 2, or some later time or whatever, right, time 1, time 2, okay, so that's all the ones, whoops, all the ones and the twos mean in the subscripts. So, let me think about it, right? And I guess I could write pressure, volume, temperature, okay, so pressure, volume, temperature, okay? You guys are familiar with those, what those things are, right? So, for example, 2, they actually give me this long explanation, right? And say, I have quantity of an ideal gas. Okay, that's the important part, I guess, to know, right? Ideal gas means that they just behave in a normal manner, okay? So ideal gas had initial values, and then they say the initial values. So first thing, right, we want to write what we know, right? So let's go ahead and write what we know. Write the known values. Oops, known values. So they said that my initial pressure, right, pressure 1 was 0.003 times 10 to the 14 in pounds inches squared. Okay, but either way, I notice like that. I'm going to leave my units off to the side for a second. So now if I want to rewrite this, okay, probably would be the best thing to do, right? Go ahead and rewrite this. So then I write 3 times 10 to the what, right? I'm moving over 3 and I'm moving over to the right side, so I'll have 3 times 10 to the 11, okay? And then they said I had initial volume, okay? So volume 1 was equal to 0.007, okay? And so if I want to change that to scientific notation too, right, then I'm going to say 7, and then it's going to move over 3 places as well, right? So 7 times 10 to the minus 3, okay? So I'm going to write the known values. V2, they gave me a T1 as well. They said T1 equals 7,000 Kelvin, okay? This one's not necessarily the most important to write in scientific notation because it's not that hard of a number, but nevertheless, it doesn't hurt. Okay, times 10 to the 3. And then they said it had a final volume. So final volume, right, or volume 2 is going to equal 3 times 10 to the 2. So they actually did this one for me. Okay, so that's good. And then they said temperature 2. Temperature 2, or a final temperature was 0.003 times 10 to the 7. Okay, and they're just trying to frustrate here, right? They're really just trying to make sure we understand how our scientific notation works, right? So I'm going to move over 1, 2, 3 places, right? So that means that I'm going to subtract 3 from my exponent up here, right? So I have 3 times 10 to the 4. Okay, now I got what I know. Okay, I got all these things because they said, hey, could you figure out what the final pressure is, right? So that's the only thing missing, right? They have P2, and I don't know my P2, right? They're just asking me to find that. So if I think about my equation up here, right, and say, oh, well, I can multiply right here, right, and go ahead and cross multiply and say, okay, well, let's see. I can cross multiply here, right? Or I can think about it a couple different ways, right? I can either cross multiply or I say, hey, why don't I just multiply both sides by, I don't know, why don't I do V2 on this side and T2 right here, and then I can do it to the other side, right? You guys see that? If I do T2, V2, my T2's cancel there, my V2's cancel there, and I can go ahead and move it over there. Okay, so let's go ahead and maybe write it out a little more formally over here. So go ahead and say, okay, P1 over T1 equals P2 V2 T2. And then we'll show this, right? So you say, okay, well, if I want P2, right, I'm going to do T2 on this side over V2. And then I'll do T2 on this side over V2, right? Because my equation is a balance, right? So if I'm multiplying both sides by the same thing, they're going up and down together. Okay, so that T2 is going to cancel with this T2, and that V2 is going to cancel with the V2. So I'm left with P2, right? Finally, P2, and then I'll have T2, P1, V1 over V2, T1. There we go. So now that I wrote on my values, okay, they're kind of hiding up there now. But hopefully you guys wrote down in your notes. You can go ahead and plug those in. They're a little bit easier to plug in now that I wrote them in scientific notation. So then I can say, okay, 3 times 10 to the 11, that was my temperature. And then I had times 7 times 10 to the minus 3 times 3 times 10 to the 4. And then on the bottom, I just had my V2 and T1, right? So there's 3 times 10 to the 2. My temperature one was 7,000, so it was multiplied by 7 times 10 to the 3. Okay, and we'll go ahead and make sure you can do that on your calculator and get the right thing. Otherwise, right, what you can do, the cool thing about scientific notation here, and I'll finish here, right, I can multiply all of my numbers that are in front here, right? So I can do 3 times 7, okay? So I can do 3 times 7 times 3. So that's 21 times 3. 21 times 3 is 63, right? 21 times 3, 63. We can do 63. And then I can say times 10, and then I can add up all my exponents. So 10, then I can say, okay, 11 minus 3 is 8. 8 plus 4 is 12. So times 10 to the 12. And then here I have 3 times 7 on the bottom, right? You see that? So I have 21 on the bottom. And then I have times, and then I have 2 and a 3, so times 10 to the 5th, right? So I'm just adding my exponents there, right? And then I can go ahead and figure out my final answers. So I actually have 63 divided by 21, right? So that worked out to be 3, right? And then what about my exponents? Well, 10, if I have 10 to the 12 on the top and I have 5 on the bottom, right? What did we learn about exponents before, right? Well, if I have x to the 4 on the top and I have x to the 2 on the bottom, right? What happens? I just go ahead and subtract those, right? So x to the second. So here, I have something similar, right? I have 12 minus 5, right? So I have just 10 to the 7th. And this is my pressure, okay? So the pressure they gave me was pounds, inches squared, so just pounds, inches squared, right? So I'd make sure you can do it in your calculator, and I'd make sure that you understand the way that we did it here as well, okay? All right, so there's one practice problem, you can go with that one, and then we'll go into lesson 70. So lesson 70, we're calling advanced abstract equations. So exciting stuff. No, not really, but hopefully you'll see that we're not really adding a bunch of work onto you, right? We're just going a little bit further here with understanding how to rearrange equations here. Okay, so we'll just say advanced abstract equations. Okay. So, right, I guess if I just put some steps here, right, you just say, if necessary, we want to distribute. Okay, and then, and the key word here is equations, okay, because then we're going to multiply through, then multiply through by the LCD. To cancel the denominators. Okay, and then right, then the other parts, oops, the other things are not going to be too crazy, right? Because then we're just going to go to the next step and we'll just say isolate what we want to find, right? So we'll isolate our variable, and then we'll go ahead and go to what we're going to call factoring, okay? So, right, so if necessary, distribute, multiply through by the LCD to cancel the denominators, isolate, factor. So let's go to our example here, right? So we'd say, okay, well, we have example 2. Let's just write out what it is. So we have XP, okay, not the operating system XP, if anybody ever remembers that, okay? XP, and then M, and then we have B over 1 plus C plus A over P. Okay, and they told us to find C. Okay, and it's not as simple as just saying, hey, I found C, it's right there. Okay, they want to get C all by itself. Okay, find C equals, something, okay? And make sure I don't look like 7. Okay, find C equals something. So we can certainly multiply through first, right? It actually doesn't make that much of a difference, but let's go ahead and distribute. Okay, so distribute, right? I'm going to multiply my m by that guy, then by that guy. So it's not going to change what my equation looks like very much, right? It's just going to be xp equals mb plus ma, and this is over p, and this is over 1 plus c. All right, so I want to multiply through by the LCD. Okay, what is the LCD here? Well, so in a simple way to think of it, right, is multiplying by all the denominators together, right? So it's saying, okay, well, the denominator of xp, what's that one? Well, it's just 1, okay? This one's 1 plus c, and then we have p. So our LCD is going to be p times 1 plus c. So if we're going to show this, right, at least I'm going to show in red, okay? But I can only do this because I'm multiplying both sides of the equations by this, right? So if I just had, right, just say if I just had this, right? If I just had these two pieces, I can't do that, right? Because an equation says that things are equal on either side, right? But if I'm just talking about a single value, right? If I was talking about a value 5, right? I can't just multiply it by 5 because then I'd have 25. Right, so same thing here, right? As long as I have both sides of the equation here, both sides can go up and down together, right? So if I have my hands on either side of my torso, right, I can go up and down together as long as I keep going up and down together. All right, so P times 1 plus C, so I'm going to multiply everything there. So that's what's going on here, right? It looks like this, right? I'm going to apply it to that guy, apply it to that guy, and then I'm going to apply it to that guy. Okay. So let's see how that works. So I'll have x p squared. So I'm going to do a little simplifying as I go here. and then xp squared, and then I'll have 1 plus c, okay, and then I'll have equals, right, if I do p times 1 plus c here, right, for this one right here, do you see what's going to happen? You see that 1 plus c will cancel there? So I'm just going to write PMB, okay, because that's going to cancel the denominator. And then over here, right, what's going to happen when I multiply here, right? Well, my p's will cancel out, right? So I'm just going to write this as MA 1 plus C. Okay, now I'm kind of stuck back in this pattern, right? I said distribute as needed, okay? So now I'm going to distribute here, right? So I'll say xp squared plus xp squared c equals PMB plus MA plus MAC. Alright, so now, what was my goal? What did they say? They said find C equals, okay? So it's like, okay, where am I? Well, I just kind of distribute everything out right now. I'm kind of ready to isolate my C's together, right? So my C's, I actually only have two C terms. This shouldn't be too bad, right? Because I only have a C there and I have a C there. So I'm going to get those on the same side of the equation. So let's do that. So I'll do minus xp squared, okay, because this is going to get rid of this one on this side. And I'll just do minus xp squared, okay. Oops, this 2 doesn't look very good. Okay, squared. And then I'll do minus mac. Alright, so minus mac over there, minus mac over here. And then if I go and look at what I'm going to get here, I'll have xp squared c minus mac equals, and then I'll have PMB plus MA minus XB squared. Okay, not very exciting letter, right? And you're like, oh man, what letters are these? Okay, okay. But anyway, we can see that all of our C's are on the left side, right? Everybody see that? Good. So what I can do, right? What was my next part? I said to go ahead and factor, right? So isolate and then factor. So I isolated them. Now I can factor, right? So I isolated them up there. Now I can factor. So here I say, oh, well, each of these terms has a C, right? So I can do C, and then what's in here, right? Well, this would be xb squared minus MA, okay? And then over here, I still have the same exact stuff, right? Same exact terms here, right? Plus MA minus xp squared. So then when I'm factoring, right, then I say, oh, well, this is kind of like, right, I have an equation here, right? 5c equals 10 or something, right? Because what do you see here? I switched the order here, right? But my c is right here. It's multiplied by this guy. So I don't know what the value of this over here is, but I can say, hey, whatever the value is, let's divide it out, right? So we'll show it like this, right? We'll go ahead and erase this part. And we'll say, let's divide by xp squared minus ma. And let's do the same thing on this side. So we'll do xp squared minus ma. Okay, I'm kind of showing a lot of steps here, right? But what happens when I do this on the left side? Well, this cancels, right? And then I'm just left with c equals pmb plus ma minus xp squared. And then over here, I have, on the bottom, I have xp squared, still the same thing that I wrote up there. So I'm kind of writing it almost duplicate, right? Because I was trying to show all the steps here. But that would be my final answer there. Right? C equals PMB plus MA minus XP squared over XP squared plus MA. So kind of to review, right? Whoops. I'm going to scroll up. Okay, kind of to review. I went ahead and distributed through everything and then made everything to where it can add up. isolated my c's on one side, factored those out, and then I can divide by whatever I'm multiplying my c to get my final answer there. Okay, that finishes 70. So if you want to look at, there's just one practice problem there, and then we'll go on to 71. All right, so 71 here, our last lesson. We're talking about the quadratic equation. So quadratic equation. So up to now, we've been solving using a couple different methods, right? We've been solving using factoring with a t-chart, and I guess when I say quadratic equation, we're talking about trinomials here. Okay, so we're talking about if we have ax squared plus bx plus c, and with the quadratic equation, we actually have equals 0. We always will have equals 0. Okay, so the quadratic equation is a general formula for completing the square. Okay, so let's go ahead and write here. So this equation says, or I guess the general form, right, says if I have anything like this right here, so if I have anything like this guy, okay, then this x equals will solve anything. Okay, and you're like, oh, really? Yes, it will. Okay, so I have x equals, and it'll be minus whatever that b term is, okay, and then it'll be minus b plus or minus the square root of b squared minus 4 times a times c. Okay, so this is all still under a square root symbol here. And then it's divided by 2 times that a term. Okay, so that's times, I don't know what the times there, right? You guys know that by now. 2 times a. Okay, we can solve any x squared equation that's equal to 0. So any x squared equation equal to 0. Okay, so like other form above there, right? So any x squared plus ax squared plus bx plus c. So first thing we need to do, right? We just need to start by identifying what those values are for our equation. Okay. Oh, and I guess before, well, I'll talk about this at the end. Okay. Let's go look at our example 1. So example 1, we have 3x squared minus 2x plus 5 equals 0. Okay, so if I want to solve this here, right, if I don't remember anything about the quadratic formula, right, I just told you that, right, and you say, how am I going to solve this? You say, hey, well, this is an equation. Can't I just complete the square? Say, yeah, yeah, we can complete the square. So we could divide, right? We could actually divide everything by 3 because this is an equation, right? And so if I divide both sides by 3, I'm not breaking any rules here, right? If there's no equation there, right? If that equation was there, I couldn't divide everything by 3. I'd have to factor the 3 out. But as it is, right, I can go ahead and divide everything by 3. And then I'd have x squared minus 2/3, oops, 2/3 x plus 5/3 equals 0. Okay, and then what am I to do after that? And then say, oh, well then if I'm going to solve the square, I just go ahead and do minus 2/3 x, and then I'd have, over here I'd have minus 5/3. All right, and then I do that little trick where I'd say, okay, I'm going to take half of this, add to both sides and everything, okay? Let's actually pause right here, and we're going to use these values that I have right here. So we'll say this is a is 3, b is minus 2, c is 5, right? And we'll use our equation that I just stated right here. So hopefully you guys wrote this down in your notes, okay? And then we'll plug them in down here at the bottom. Okay, so we'll do x. I'm going to scroll down a little bit past here, right? I say x equals, hey, what was b again? B was minus 2, right? So if it's minus 2, then it'd be minus 2 plus or minus the square root. And it's a b squared, right? B is what again? It's minus 2. So that means I have 4 minus 4. And a was 3. And c was 5. And then on the bottom, right, I can divide both sides by 2a. My I have 2, and then a was 3, right? So 2 times 3. Okay, so again, right, I guess if I want to go back up here to this one, it's a negative of not doing it right next to it. Minus b plus or minus b squared minus 4ac over 2a. So you guys should have that in your notes as well, so you can refer to that. Okay, now let's simplify this. So then we say, okay, well, then that's 2, and then we have plus or minus. Then we have, what are we going to get in here, right? We have 4, and then we have 4 times 3 times 5. So that's going to be 12 times 5. It's going to be 60, right? You guys see this whole term is going to be 60, right? So it'd be 12 times 5, 60. So we have 4 minus 60. Oh no. Well, 4 minus 60, what's that? Well, that's going to be minus 56, right? So we'll put minus 56 here, and then we'll talk about simplifying that in a minute. Then we have 6. Okay, so now if we want to simplify this, what do we learn about negative square roots? Well, we learned that they are not possible to actually get to a real number, right? So we'll say 2 plus or minus, and we know that we can pull an I out of them. So we have square root of 56, okay, and we have an I attached to it. And then finally, right, we could say, hey, this is actually 1/3, and then we could simplify this part if we want to. Plus or minus I, I square root of 56 over 6. Okay, that's pretty much how it goes, right? The only thing that I could simplify here is I could say 1/3, and then I could put a square root of 4 into 56. Okay, here, I'll do it over here on the side in red. Square root of 56. Whoops, not 56. 56. I could say it's the square root of 4 times square root of 14. Okay, and then I just end up getting 2 square root of 14. Okay, so if I did that, then I have 2 square root of 14. Oh, forgot my I. I want to forget my I. 2i over 6. Okay, and then if I was going to simplify from there, then I'd have 1/3 plus or minus I root 14 over 3. Okay, main thing is a lot of work to get to that point, okay? But you can see, I think you can see what I did there, right? If you got to this part up here where you're like, oh, I got it, right? That's gonna get most of the credit. It's just writing it in its simplest form is what we would like you guys to do. Okay, so right, what did I do? I used my equation here, x equals minus b plus or minus b squared minus 4ac over 2a. And you say, yeah, well, why did that work? Well, I'm not in practice A. It says for you guys to derive the equation, writing it, all those. But I would go to your page in your book here. See, make sure what page it is. It's page 297. Page 297, and you guys will see how they derive the equation. Okay. And you say, oh, derivation is scary, right? It's not that scary. Okay. It's basically they're solving the square and they're finding a general form of solving the square. So let's go down here and let's solve the square for this guy, right? Hopefully I don't lose you guys here, but I'm just going to show you guys, right? What was our solving the square? We said if we're solving the square, we say, hey, what is b? And hey, b is minus 2/3 right here, right? Then we say, hey, what is b over 2? We say, oh, well, b over 2 is minus 2 over 6, right? And then we say, what is b over 2 squared? And we say, oh, well, that's 4 over 36, right? Okay, and then over here, what we did is we just went ahead and said, let's go ahead and add b over 2 squared to both sides. And we say plus 4 over 36 plus 4 over 36, right? We can do that to an equation, right? Because if we add something to both sides, like I said, I'm holding my hands out, my torso is like the equal sign, right? Then both sides are going up by the exact same amount, okay? All right. And then, right, when we said from there, then we said, hey, you know what? You actually can figure out what this is going to be, because you could just say, hey, what this is going to actually is going to be x minus 2, 6, or I guess I could have just said 1/3, okay? um, 1/9, right? I guess I could have written that there. And I could add it together, right? But anyway, minus, here I'm going to get my eraser, minus 1/3. And then over here, right, I can do the same thing, right? 12, so it's going to be 60, and you'll find out that this is going to be minus 56, okay, over that 6 here. Oops, 36. Okay, so we're minus 56 over 36. That looks familiar, right? I mean, you see that, right? So then when I solve this, okay, what do we do before? We said, hey, take the square root of this, take the square root of this, and then we have x minus 1/3 equals, and then I'd simplify this and I'd say it's the square root of 56 over 6. And then I would just go ahead and move my 1/3 to the other side, right? And I'd have x equals 1/3 plus or minus, um, oops, plus or minus I square root 56 over 6. Alright, so I can solve the square and I can figure out the answer exactly the same way, right? Because that's the exact same thing that I had down here, right? Exactly the same as right here. It's just I used a formula for it the second time, right? It's the derived formula. Okay, so but hopefully you can see this. This is going to be a big help if you memorize this for the equations later, because you won't have to solve the square the whole time. But you can, and it's a good idea to just see how they're related. And I think that covers it. So if you have any questions, hopefully I'll see you on Friday for tutor sessions. Otherwise, send me an email. Get help some way, okay? And I'll see you guys next week. Be safe. Bye-bye.